That's my jam. All right, here we go. Number 8. 11.3, numero 80. This is not how anybody in the world speaks. All right, let's see. Rotational inertia of a meter stick. Oh, this is a good one. And if you were one of the people that struggled with 13, it uses the same trick. Okay? So here's what number 8 says. It says, calculate the rotational inertia of a meter stick that's got a mass of 0.56 kilograms about an axis perpendicular to the stick and located at the 20 centimeter mark. All right? So the idea is this. If you look at our rotational inertia sheet, oh, too far. There are two sort of equations that deal with a thin rod. Notice, and this is important, you guys, it says here of any cross-section, so it doesn't really matter what these rods are shaped like. What's important is that they are much longer than the other two dimensions. Make sense? So it could be a long cylinder, or a long square, or a long rectangle, or a long whatever. A long triangle. Doesn't matter. Okay? As long as it's uniform. That's the important thing. So this one tells us how we would calculate the rotational inertia of the meter stick if we pivot it at the center, the 50 centimeter mark. Cool? This one tells us how we would find the rotational inertia about one of the ends. Which one is bigger? Which one has more inertia? This one, right? Because the mass is farther out now, right? Okay. Mathematically, this r is bigger than this r, right? Okay. So what the question wants to know is this. It doesn't want to know the rotational inertia about the center or the end. It wants the rotational inertia about the 20 centimeter mark. Okay. So anytime you're doing this, you guys, you've got a shape, and you're like, oh, I know the rotational inertia of that shape. Oh, but the pivot point isn't where I thought it was going to be. It's at some weird point. All right? That's a sign that you use the parallel axis theorem. All right? So if you missed that in the notes, again, the parallel axis theorem says that the rotational inertia about some pivot point of any object is equal to the rotational inertia of that object about the center of mass plus mh squared, where h is the distance between your center of mass and your new pivot point.
So you couldn't just like bisect it at the 20 and then just add the 2?
Oh yeah, that's what it is. Is it really bisecting if it's
you could also do it that way. So you treat this as a uniform rod pivoted about one end, treat this as a uniform rod at the other end, and then add the 2. I believe that should work.
Yeah, that works.
That does work. Okay. All right. That trick will not work on number 13 then. Okay? So this parallel axis theorem, you guys, is very, very useful. Okay? Suppose I knew the rotational inertia of this mess. All right? And then I took it off, and I said, now what's the rotational inertia? Okay? Stop. All right. All right? So that's the deal there. All right? So for us, which one of, well, so I want the rotational inertia about the center of mass. So I'm not ignoring you, McKeever. Give me 1 minute. Which one of these would I use for center, the eye around the center of mass? The first one or the second one? The first one, right? Because this has the pivot point at the center of mass. Okay? So for a meter stick, what would R be? 50 centimeters, right? So for us, here we go. I, about the center of mass, is 1/3 the mass times R squared. Okay, and that gives us a number that I don't know, but I have a calculator right here, and the calculator knows. So 0.56 squared divided by 12. So you get 0.02613. Cool? Kilogram meter squared. All right? And then mh squared is going to be 0.56 kilograms times, what's h? I'm moving my pivot point. It's no longer at the 50 centimeter mark. It's now at the 20 centimeter mark. So the h is 0.3.
Not negative. Oh, okay, never mind.
The positive, negative doesn't matter. It's going to square out anyway. Okay, so that gives us 0.56 times 0.3 squared. That gives us 0.0504, and then you just add your two answers and you're done. Camp?
How'd you get the, for the center of mass, like the inertia for that, I got a different number, and I don't know if it's just on the calculator or...
I don't know. Let's see. It's 0.56 times 0.5 squared, and then divided by 3, right? Oh, I apparently wrote it wrong. Or typed it wrong, rather. Sorry, Dan. You're right. My bad. Thank you for correcting me. Is that better?
Yeah.
Sorry about that. So yeah, if you missed it, sorry, I must have typed it in my calculator wrong. Oh, I just called you Dan. Sorry, I wasn't looking. That wasn't me not knowing you. That was just me not looking up. Okay, are we good? McKeever, what were you going to ask before?
Well, for 13 eighths divide, like, okay.
Hold that thought. Is everybody okay with 8?
Yes.
Any questions on 8? Cam, you okay? All right, so you just add those two and you're done. Any problems with it? Okay, so that was 8. We did 9. I guess we might as well talk about 13 then, since we're on that subject. Oh, hold on. Let me